We're talking about energy. 21% of all the energy in the United States is consumed by homes. $160 billion is spent by Americans to power our homes each year. Today, the average household expenditure for energy is $1,900, and it seems a pretty good bet that energy prices will continue to rise. But a 20 to 30% savings is possible by making homes more energy efficient. Now, we're talking about energy at home.
Production of this program was made possible by a grant from the West Penn Power Sustainable Energy Fund.
The same brightness, the same white light. But the compact fluorescent bulb on the right uses a quarter of the electricity and can last much longer than the one on the left. Replace just a few bulbs in your house with compact fluorescents and you'll save money every month, every year.
Compact fluorescent light bulbs can use up to 75% less energy than tungsten bulbs. If replacing a single tungsten light bulb in your house with a compact fluorescent can save you about $17 per year, just think what other bright ideas there might be to save energy and money at home. Hi, I'm David Price. They say in life the only certainties are death and taxes, but we can probably add the rising cost of energy to that list. In this show, we're going to look at ways to reduce your home energy consumption.
I mean, a house is clearly the largest investment most people will make in their life. Houses have trended to get larger. If you look at post-World War II housing, you were slightly under 1,500 square feet. That's grown to almost 2,700 square foot per home. Plus, the number of people living in a home have been steadily decreasing. As far as the overall energy usage, the residential sector accounts for between 21 and 25%, second only to transportation.
The Energy Information Agency estimates that the residential sector accounts for 21% of greenhouse gas emissions in the country. Whatever we use in energy directly causes emissions at the power plant or at our furnace if it's a gas or an oil burning furnace. Anything we do to reduce the energy use of our houses is going to almost directly translate to reduction in greenhouse gas emissions.
Most people think of an energy bill as something that is a fixed cost, something they have no control over, when in reality the decisions they're making at time of construction and as they're buying appliances or things that are using energy, that clearly makes a difference in the overall energy impact of that home.
So let's first take a look at building a new home. How can you know if you're building an energy efficient home?
It's difficult because the energy usage of a home is invisible. The idea of somebody building more energy efficient than the next person, it's difficult to quantify when you're looking at a set of plans or you're working to pick a builder.
To get some insight into what makes a home energy efficient, we're going to follow the building of an Energy Star house. Energy Star is a program of the U.S. Environmental Protection Agency and the Department of Energy. It was started in 1995, and to date, more than 1 million homes have been built to Energy Star standards.
We could get into the slope portion of it and pick up a little more space.
Might add a little character too.
There are really two reasons why you would build an Energy Star house. Number one, the comfort level is going to be much greater than it is in a standard house. And the other reason is you're going to save 20 to 30% on your fuel bill compared to what the model code requires.
Well, a standard built home is one that is built to at least meet energy code. Each state determines the code that will create the minimum level of energy performance that's required for new construction. Energy Star is designed to be an above-code program. Builders and home buyers participate on a voluntary basis, and they can expect a home that is going to perform better than that code-built home.
The first step in the process is basically to agree to be an Energy Star builder, and you sign a contract with the Environmental Protection Agency stating that the homes that you build that will be Energy Star rated, you will comply with their program and their specifications. From there, you have to select a rater that will work with you to analyze and to rate your homes.
We like to work with the builder starting as early in their process as possible. The builder will provide to us their plans and specs for the home as they originally intend to build it. So regardless of what they're planning on putting in, we'll run that through some energy modeling software, and we will end up modeling a predicted energy performance for that home as planned. And we'll compare that with the Energy Star standard. And we'll come up with a package of improvements over and above what they had originally intended to do. What kind of windows? Are they Energy Star rated windows, for example? What kind of heating and cooling system makes a huge difference? What is the efficiency of that system? Where are ducts going to be located? And then what are their expectations of their contractors?
It really wasn't that big a deal for us. They made recommendations around the tons for our HVAC systems. That was a minor adjustment, but what it did is it ensured that we're putting the right size systems in our homes and not oversizing or putting too small systems in our homes.
After you meet the specs that Energy Star wants, then you have to learn how to build the Energy Star house.
To a higher standard than code, in this case.
A house isn't built by an individual builder.
So what we're doing is we're building an Energy Star house.
It's a team of people that build a house. There's everything from the framing crew, the foundation crew, to the HVAC contractors, plumbers, electricians. I mean, all those are independent contractors. And each one plays a role in how that house will perform.
The homeowner can typically turn it on and off for use while they're in there.
Both of its systems, but also the energy efficiency of the home really depends on the integration of all those systems together to work well.
The framing acts as the draft block that I was looking for.
So we're good.
You get the subcontractors out here who are going to be doing the work, and you walk through specifically what Energy Star wants out of the house.
What we're looking for here is a complete air barrier on both sides of the insulation.
The meetings were quite extensive,
So that will get insulated correctly.
and the engineers were quite detailed in what they wanted.
You want that mastic to everything.
Everything.
We've learned an awful lot over the last 10 to 20 years working with energy efficiency programs.
I imagine the insulator would do that.
One of the most significant things we've learned is that it's not so much about technology,
All right, make sure that gets airtight.
but how the house functions as a system. In fact, we call it house as a system. All of the materials and systems within a home interact together.
Framing is, believe it or not, important in an Energy Star house. You want to get as much of the exterior surface of the house have insulation on it. You want to try to get that insulation in every little corner that you can. We'll have to insulate that before we button it up.
We pay a lot of attention to the air sealing of the building envelope because all those gaps and cracks and penetrations that are created during the construction process can add up to the equivalent of leaving a door open in your home during the winter. Even though each one may not look like very much, in aggregate, it can make a huge difference.
Oh, it makes a huge difference. You lose 30% of your energy through these little cracks here. And what our job is to come in, seal them up using a foam or a latex caulk, seal the air from getting into the house. Like this, your energy stays in the warm area. See where the two stick of lumber join together? You need to come down there and seal that.
I think before house wrap and attention to sealing, using foam and gaskets and such, infiltration or air leakage in a house accounted for sometimes 50% of the heating and cooling energy use in a building.
With the Energy Star program, we're really not relying on high-tech fixes or expensive technologies that are going to somehow revolutionize the home that we're building. It's actually the lower tech and lower cost measures such as air sealing that really deliver the greatest bang for the buck. Products like caulk and spray foam that seal all of those penetrations are extremely cost effective. Their impact on energy performance can actually be huge, and the cost of installing them is not.
So far, it looks like you can do some things in the initial design to help with energy efficiency, and then you can turn to the details and look at reducing air infiltration and maximizing insulation. That will help with efficiency too. By the way, there are a number of types of insulation available. You can use fiberglass, cellulose, and sprayed-in foams. The house we've been watching uses a blown-in fiberglass after the walls were sealed with a spray foam. So there are technological advances that help you raise the home's efficiency.
Both of these homes are nice and toasty in the winter. But if you install a ground source heat pump like the home on the right, you'll save money every month. A ground source heat pump heats and cools with the earth. With the money you'll save, you and your sweetheart can relax in style. Install a ground source heat pump and save money every month, every year.
The beauty of a ground source heat pump is instead of an ordinary heat pump that exchanges heat with the outside air, which can get very cold in the wintertime, it exchanges heat with the ground. Because the ground temperature stays roughly the same year-round, that heat pump runs much more efficiently than an ordinary heat pump. And by my studies, it's actually about twice as efficient as an ordinary heat pump. And an ordinary heat pump is about twice as efficient as electric heating.
So it looks like we made progress in better technologies and how to apply those technologies. So if you're building a new home, you have the chance to consider new products and more efficient products. Heating and cooling equipment, lighting and insulation, roofing, and windows and doors are among the products that meet energy efficiency guidelines that earn the ENERGY STAR label.
I guess there's a whole lot of things that have happened in the last decade or two as far as home energy efficiency goes. Windows is probably one of the biggest contributors to efficiency.
Years ago, windows were wood. They were single pane windows, putty glazed. That's back when the storm window business was very popular, trying to put a storm window over an old wood window. The new glazing today is double glazed glass, and actually beyond double glazed glass is the low E glass now. Low E glass is a coating on the glass. This low E glass helps reduce the U value of heat transmission on the glass level. Also, the coating helps reduce fading of furniture, carpets in your home.
If we spend a little bit more on a higher performing window, that can actually enable the heating and cooling system to be slightly smaller because the heat and cooling load of the home has been reduced. So a better performing product in one area gains in efficiency in another area.
I mean, it really comes down to the fine details, such as air sealing and sealing of our HVAC systems, to ensure that we're building the home according to the ENERGY STAR specifications. All of those little details put together make for an energy efficient home.
So nothing from the attic can get to a warm space that's not protected.
Once they start work, we walk through that home and see just how some of these features are being built into the home. And we'll provide feedback to the builder and their contractors about how they're doing.
You're going to have small areas of bypass, so you would insulate this as a band space.
The objective is that by the final inspection, where we're actually doing some testing on the home, we have a reasonable expectation that it's going to pass, because if we hadn't looked at it earlier, it becomes very difficult to make changes later.
Fill this bay from bottom up.
So we're looking at it before the drywall closes everything in. We're looking at the insulation,
covering the bottoms,
and all those other things that you can see at that stage.
The ENERGY STAR Homes program uses a third-party verification of the performance of the home.
Fill up these bays.
Is the insulation installed right? Is the duct system designed and installed properly? Are all these systems married together in an optimal way?
You've got it down here, you have to do it up on top.
That ultimately will deliver performance.
You want to bring it down so that it can run with your drywall.
All right.
So it's almost a quality control mechanism as much as anything.
You want to seal these rather than fiberglass these.
The true value of ENERGY STAR is basically the fact that there is a label put on the house by a third-party independent building rater.
The big item that you have is insulating that floor space. It's going to be tough, but you got to make a choice on that.
It's not like a builder saying, of course my house is energy efficient. My question to that is, says who? Our answer to that is the federal government says that the house is energy efficient through labeling the house with an ENERGY STAR logo.
We good?
The home on the left has an Energy Star labeled washer. The home on the right has a different kind. Energy Star appliances work great, save energy, and save you money. With those savings, you might have a little extra cash to spend on the finer things. When you shop for a major appliance, look for the Energy Star logo and save money you can use every month, every year.
And of course, Energy Star homes come with Energy Star appliances, appliances that are designed to consume less energy.
At the end, prior to occupancy, that's when we're going out and we do some tests that include what we call putting it in winter conditions.
3/4 of a CFM.
We put this piece of equipment called a blower door into the door, which exaggerates the air leakage of the home and allows us to see how the air is moving through the home. We put a separate fan onto the duct systems. We see how much is being lost through those, because we know that one of the greatest energy wasters in a home can be a duct system that's not well sealed or hasn't been installed properly.
The ductwork is leaking 59 CFM, which is less than 2%, which is great, wonderful. That's what we're shooting for.
So with all of this equipment, we're doing that final test.
So now what you have is a couple of small things: the hatchway, basement penetrations, and your finish work. You got an Energy Star house.
You got it. Yeah. There we go.
I think the Energy Star program does cost a little bit more for us to build the homes. I mean, there are things that we have to do a little bit differently than with the building codes. So I think, though, that extra cost in the home is a big benefit to the consumer of a home, because the more they make it up in energy savings throughout their living in that home.
An Energy Star home will have fewer callbacks from the customer related to the performance of the home, which translates to reduced cost for the builder, but also for the contractors. They're getting called back to take care of minor deficiencies and so on, less than they would have been. And that's good business.
I think right now, with the oil situation being as fragile as it is, people are really aware of the market that's out there and the problems that exist. It's definitely advantageous for us to be an Energy Star builder. We did that for that reason.
So, building a new energy-efficient home doesn't have to cost an arm and a leg. As you've seen, much of it is not high-tech. It's in the details. Same holds true for an existing home. And that's what we're going to look at next.
In the winter, if you let your house get a little cooler when you're not home, and in the summer when you aren't around, if you let your house get a little warmer, your heating and air conditioning won't work as hard. You'll save money. Also in the winter, turning your thermostat down a bit more at night can add to your savings. And letting your house get a little warmer while you're out of town in the summer can save you even more. So in the winter, turn it up before breakfast, you turn it down before you leave, you turn it up when you get home, you turn it down before bed. Or get an easy-to-set programmable thermostat, and you'll save money automatically.
So what if I'm not building a new home? What if I already own a home and want to reduce the energy cost there? An automatic setback thermostat is one way to do it, but to find out the possibilities, it takes an energy audit. So I had one done to my home. Hi, I'm David Price.
Liam Goebel.
Goebel?
Nice to meet you. Good to meet you.
An energy audit is done by a certified home energy rater, and there is a growing number of companies offering this service.
Basically what I do is take exterior measurements of your house. I then determine the direction your house faces.
The sun rises there and gives us full sun all day.
Okay. After that, I'll take measurements inside, measure the windows, measure the doors, check your mechanical systems, your hot water heater, your furnace, just to see how efficient they are.
Okay, let's get to work.
The first thing we do is measure the dimensions of the home, the locations of windows and doors, and the direction the home faces with respect to the sun. In our climate, the sun can both help you and hurt you. In the winter, the sun can add valuable heat content to your home, depending on the glazing on the southern face of your home. In the summer, solar load is something much less desirable. The process of the audit involves a thorough walkthrough of the home and inspection of all the major systems and methods of construction in the home.
This room outside, it's on the verge of being a death trap.
That includes the thicknesses and levels of insulation in the walls, the number of panes in the windows, and the age of construction.
Sitting in my living room, if I put my hand against the wall, it's actually cold.
We often find homes that are uninsulated or under-insulated in the attics and in the walls. Yet often air infiltration is the easiest means of improving the performance of a home.
The house actually stopped here.
The audit really has three parts.
And there's the basement.
One is the actual inspection of the home, where our rater is on site, taking measurements, doing the infiltration test with the blower door.
There's nothing, no insulation below us.
Thoroughly documenting the home.
There's no insulation there.
The second phase is to come back to our office and perform modeling work. The rater enters all of the pertinent information from the home, the dimensions, the types of equipment, levels of insulation. The software can run a series of scenarios of the current state of the home and how it's performing compared to energy standards of the day. The software can also run a number of improvement analyses on the home where we actually look at specific improvements and the effect they have on the energy consumption.
Got the results back from your home energy audit.
The final stage is really the most important in my opinion.
This is a rough cost for energy usage for your house.
That's the education with the homeowner.
It says about $3,000 a year. So your house is about 58% less efficient than a home built to code standards today.
Sitting down, not just to hand them a report, but to explain concepts and answer questions.
Do you have any questions?
Yeah, I do. I'm looking at 23 recommendations. Do you have, say, the top 2 or 3 things that could make the biggest impact?
Yes, the infiltration would cost about $150.
When I see changes happening, it's when people are educated.
You'd have a simple payback of about a year.
What's simple payback?
It's the time your investment takes to pay itself back.
They're empowered with knowledge, but they're able to make reasonable choices to improve their energy usage.
Getting some attic bats in my flat ceiling, the cost is at $3,000 and change.
You'd end up saving about $600 per year and about a 5-year payback.
Is that for me, the semi-talented homeowner, to do, or somebody who knows what they're doing to do?
We like to put together a list of quick fixes, things that can be done piecemeal on nights and weekends, including insulating the attic and the rim joists in a basement.
You know, 1 bat a week, you could just go up there, roll it out.
Halftime, roll a bat. Halftime, roll a bat.
Reducing air infiltration, draft sealants around doors and windows, and utility chases. So there are quite a number of things the average homeowner can do themselves on nights and weekends to make a real difference.
Do you have any questions?
Nope.
All right.
The house is inefficient.
Both of these refrigerators work great. But according to their energy guides, the left refrigerator uses quite a bit less energy than the one on the right. So it costs you less to run every year. Both keep your food fresh, but one costs less to operate. So if you like fruit, you can buy more of it. Compare before you buy. You'll find energy guides on every major appliance.
So saving energy translates into saving money, and for people who are on a limited or fixed income, keeping those operating costs down can be really important. And for the folks who spend a large percentage of their income on housing, an energy-efficient home can have a real impact.
This is the first Energy Star home in Fayette County, and we hope that it's the first of many.
When you talk about affordable housing, you're talking to individuals 60% of median income, and in some cases, special needs, 20% of median income in different parts of the Commonwealth. Statistics have shown that most homeowners, their total housing costs, it used to be, the benchmark used to be 30% of their total income being spent for housing.
The EPA Energy Star label.
Well, that's going out the window. We're now seeing in excess of 50%. And energy is a big piece of that. We are the Commonwealth's leading provider of affordable housing. We build affordable rental apartments throughout Pennsylvania. We also lend money to developers to build apartments.
Developers apply to the Pennsylvania Housing Finance Agency for financing to build affordable housing. And now energy efficiency is part of the evaluation of those proposals.
In order to get our tax credits to do their development, they have to consider energy, and that's where we wanted to be out front. So it's now mandatory that they consider that as part of seeking the funding from PHFA. So if we can reduce all of those costs, realizing that in certain markets they're going to have to pay a certain amount of rent or a certain amount to buy a home, but at least let's go after and reduce the cost for energy. Besides, it's good for us, it's good for our children's children.
We started talking about energy and how much our homes consume and how much that might cost us. But we've seen that with not too much effort, both new and existing homes can be made much more energy efficient.
The more energy efficient you can make the home, the more insulated you will be from large swings in energy prices into the future. The oil supplies are getting tighter and tighter. Natural gas prices are the same thing. You have one natural disaster and prices go sky high. I mean, where a lot of the research is going at a federal level is heading towards a zero energy home.
Now, how do we do that? You basically combine all of the good ideas that we've talked about: ground source heat pumps, good windows, air tightness, ventilation, air heat recovery, good insulation in the walls and the ceiling, and very efficient appliances as well. Then it becomes feasible to add a solar electricity system and combine it with a solar water heater too.
Well, we've learned that my house definitely is not a zero energy home, and that there are lots of things that can be done to improve existing homes. Most of it seems to be in air infiltration and insulation. But the energy audit gives you the full picture.
This is the state of your house as it is now.
Third-party inspection seems to be a key in building a new home, as we saw with our Energy Star example.
Air barrier, thermal barrier.
Here again, it all seems to be in the details. Bottom line, reducing energy demand will lead to a reduction in energy cost. We've seen it in new housing, existing housing, and affordable housing. There's a lot of information out there. Saving energy leads to saving money if you know what to look for and what to ask for.
Production of this program was made possible by a grant from the West Penn Power Sustainable Energy Fund.
To find out what you can do to save energy on your existing or planned new home, go to pahomeenergy.org. This website is a complete resource for home energy savings. That's pahomeenergy.org.